Now I did realize that I didn't show you the typing in on the calculator, so let me just do that on the calculator. Yes, you want to put in those parentheses around 1/3. If you don't, the calculator will give you a different answer. The 11 times 11, go ahead and put that in parentheses as well. You'll learn that parentheses are important in order for you to tell the calculator what to do. Moving on to lateral area, again I'm looking at my formula sheet and I'm writing in the lateral area formula, which is 1/2 times the perimeter of the base times, and this is a lowercase L, which represents a slant height. So a slant height is just like it's called, slanted, and that goes on the side, on one of the faces of your pyramid. So this here is our slant height, but notice we don't have that length. So what we're going to need to do, we're going to need to connect the height with the slant height and solve for our length that's missing. So we end up getting a triangle where here's our slant height, here's our height, and here is half of 11. Okay, so this ends up being our Pythagorean theorem. We do know the height is 12. So we have, be careful here, this is always going to be your C value. We have, I'm trying to figure out where to write for space, I'll just write it here. We have 12 squared plus 11 halves squared equals to our slant height squared. Now don't worry about the 11 halves, we can just type that into the calculator. We got 12 squared. Since it is a fraction, yes, you want to put that in parentheses. We do end up getting a decimal, that's okay. So you get 174.25, and then we're going to take the square root of that on both sides. Now here's on the calculator, here's a trick, don't type anything in, you can just do second x squared to get that square root button, then second again, and this negative button down here at the bottom, which will give you the answer, which we had at 174.25, which gives us a slant height of about 13.20. Now this one is asking us to round to the hundredths place, so it is okay to round that to 13.20 or just 13.2. So let's go back to our lateral area now that we have our slant height. So we're going to write in that 1/2 perimeter. Okay, what's a perimeter? Perimeter is adding all of the sides together of our base. So we got 11 plus 11 plus 11 plus 11. And our slant height of 13.2. I am going to write that out one more time. Looks like I need a little bit more space. So we had 1/2 times 11 plus 11 plus 11 plus 11 times our slant height of 13.2. I'm going to type that into the calculator. 1/2 11. You can do 11 times 4. And again, it is asking us to round to the nearest hundredths place. So we have a lateral area of 290.4. And again, what are our units? Centimeters. Area is squared. For surface area, if you take a look at your formula, surface area is our lateral area plus 1 base area. So lateral area is going to be our answer from here. So we had 290.4. You can do 0.40 since they do want it to the hundredths place. That's okay. Plus our base area. Okay, what's our base? Our base is a square. What's the area of a square? Length times width. So we got 11 times 11. And we only have one base, so we only do once. So 290.40 plus 11 times 11. And I get surface area is 411.4. And again, since they are wanting to the hundredths place, it is okay to write that 0. And again, area is squared. All right, moving on to the next one. This one you want to be careful on naming. This is not a pyramid. In fact, this is a triangular. You can see the triangle here, and you can extend this out if you want to see it a little bit better on the back. So this is a triangular prism. So here's one of the bases, here's one of the bases. Remember, if you see a triangle, it's a triangular prism. If you see a rectangle, it's a rectangular prism. If you see a trapezoid, it's a trapezoidal prism. Okay, so this is a triangular prism. Again, I'm going to take a look at my formula sheet. Here's my volume. We have base area times the height of the prism. Lateral area, I'm just going to go ahead and write out all my formulas. Perimeter of the base times the height of the prism. And surface area is our lateral area plus 2 times our base areas. So since we are at a triangular prism, that means this triangular is our base. So here we have a 4 centimeter. Here we have a 3, this cut off, so I'll make a note of that, 3 centimeters. And unless you know your Pythagorean triples, you might want to do the Pythagorean theorem to find out what this side is. I already know this is a 3, 4, 5 triangle, so this is going to be 5 centimeters. That means when I calculate the base area of a triangle, it is 1/2 times its base, which is 4, times its height, which is 3, times the height of the prism. So it's not the height of the triangle, but it's the height of the prism, which is this right here at 7 centimeters. Oh, and I think I put 1/3. That was silly. 1/2. I think I was thinking about a pyramid. Nope, this is 1/2. Hopefully you saw that before I did. So we get, you can do 4 times 3 divided by 2. That's fine. Or if you do it using a calculator, we do need that 1/2 in parentheses, like a separate parentheses. Otherwise your calculator is going to do other things. And we get 6 times 7, which is 42 centimeters. Volume is cubed. Okay. Perimeter of the base is when you take the base and you add all of its sides up. So we have 3 plus 4 plus 5. The height of the prism we already know is 7. So we're going to add all of that and multiply 3 plus 4 plus 5 times 7. And I get 84. Area is squared. Again, taking that answer, plugging it into our surface area, so we get 84 as our lateral area plus 2 times base area, again, is the area of a triangle for this triangular prism. So we get base is 4, height is 3. Now I can't just look here. We already know that the base area is 6, so I technically don't need to calculate this little section. You can if you want to. If you just want to kind of plug things into the calculator, you can. And this was already 6. So we get 84 plus 2 times 6, which gives me a 96 surface area, that is centimeters squared, since area is squared. Okay, for the last one, looks like we have a cone, like an ice cream cone. Here we notice that things are provided to us and not provided to us. With 13 is a slant height. Height is not provided to us. And again, I'm going to take a look at my cheat sheet here for a cone. Notice that I give you 2 formulas here. You can use either. Just understand that the base of a cone is a circle. So when we talk about a base area, we're talking about the area of a circle. So I'm actually going to use the bottom one, so that way I don't have to write things out twice. So volume was 1/3 times pi r squared times the height of the cone. That's volume. Lateral area was pi times r slant height. And surface area is our lateral area plus 1 base area, which was pi r squared. So the cone and the pyramid have pretty much the exact same formulas, except the difference is with pyramids, there's different bases. With cones, the base is always going to be a circle. So we got 1/3 times pi, our radius is 10, so 10 squared, times the height of the cone. Notice that we actually don't have the height of the cone. So once again, we're going to go into our previous knowledge and do the Pythagorean theorem. Now on the cheat sheet, I did write out the Pythagorean theorem for you. Just know that C is always across the street from your 90-degree angle, so please be careful about that. So again, we have h squared plus 10 squared equals 13 squared. Subtract 10 squared. You can also do 100, that's fine. I got h squared is equal to whatever 13 squared minus 10 squared is. And I'll bring that up so you guys can see it. So we got 13 squared minus 10 squared, and I get 69. So h squared is equal to 69. Take the square root of both sides. Square root of 69 is a decimal. Now again, that's okay because it is asking you to round to the hundredths place. So when I have 83066, the hundredths place is this 0, so I'm going to take a look at the number behind it. Since that number is 6, I'm going to round to 8.31 as our height that we're going to place here. And I'm going to put parentheses because we have a multiplication symbol and a decimal. I don't want that to get confusing. So when you type this into the calculator, there's going to be a couple parentheses. You do need parentheses around that 1/3. You do need parentheses around that 8.31, and the only reason I'm doing that with the parentheses is because we do have that multiplication symbol already there. Open 1/3, close it, times, open. Now this pi needs to be the pi button. You cannot use 3.14 times 10 squared. You can omit the parentheses here and just do 10 squared, close it, times, open, 8.31, close it, enter. Now again, it is asking you to round to the hundredths place. Hundredths place means 2 decimal places, 870.22. Next number we have after the second number is 1, so we're going to keep it at 2. Units are not provided, but that means you still have to write a U for units. Even though units are not given, U for units. Volume is always cubed. Okay, lateral area, we have pi times r, which was 10, times our slant height, which was provided to us at 13. Now, if they want exact answers, you would do 13 times 10, and say we have 130 pi units area is squared. This is exact, but because they are asking you to round, we're going to go ahead and do pi times 10 times 13 and round to the nearest hundredths place at 408.407, and I did that on purpose. This is the hundredths place, so we're looking at the number behind it. Since it is a 7, we are going to round up to 408.41 units squared because area is always squared. Okay, taking that number, bringing it towards our lateral area in the surface area formula. So we have 408.41 plus pi, radius is 10 squared, type all of that in, 408.41 times pi times radius squared. And again, we are going to round to the nearest hundredths place. We get 128.305. Something's not right. That seems a lot. Oh, you know what I did? I want to show you. I multiplied pi instead of adding, so this is wrong. It seemed like a little bit of a larger number. So let's go ahead and not do that. I'm going to go up and over. I'm not going to retype everything just because I don't need to. I'm going to change that multiplication into addition and actually use the proper formula. That's better. 722.569. And again, I am writing extra numbers to show you how to round. This is the placement we want, the hundredths place, so I'm looking at the number behind it, which is 9. So that means I have my surface area at 722.57 units squared. Let's go ahead and move on to the second page. Find the lateral area and surface area of the cylinder. So we're still using our formula sheet for this. They are telling you what this is, and instead of rounding, this one is actually asking you to leave your answers in terms of pi. When they do that, that means you are not going to be typing in pi into the calculator. Everything else gets calculated except the pi button. Since we know that we want lateral area and surface area, I'm going to go ahead and separate this out. There's lateral area section, there's surface area section here. Lateral area of a cylinder, again, I provided two formulas for volume. Base area is a circle, so you can just write the pi r squared. You don't have to use both. So, oh, do you guys see what I did? I gave you volume when it's not even asking for volume. Lateral area and surface area, so I don't even need this one. I'm going to jump right over here for the actual formulas that they want. So lateral area is equal to 2 times pi times r times the height of the cylinder, and surface area is equal to our lateral area plus 2 of our base areas of pi r squared. Let's go ahead and fill in our information. 2 times pi times radius. Now, again, they are giving you the diameter, but we want the radius. So a radius is half of the diameter, so the radius is 20, and then the height is 32. Now, because they want us to leave answers in terms of pi, we are not going to be typing in this pi. That pi stays, and we are typing in 2. We are typing in 20 and 32. Leaving terms of pi means pi does not get typed in. So 2 times 20 times 32. And it gives me 1,280. Again, we did not type in pi, so pi stays. And then we want our units. Centimeters. What are we finding? Lateral area. Area is always squared. This is your exact answer. We're still going to take that answer and plug it in. When you plug in lateral area here, you are taking that pi. That pi is included in your calculations. Radius was 20, again, half of the diameter. And one more time, we are going to not include our pi. Now, how to do this? There's different ways of doing this. You can just type in everything except your pi's. So 1208. So make sure you can see my calculator. Plus 220 squared. And then just write in pi at the end of your answer. The other way of doing this could be to calculate this without pi and then calculate it this without pi and then add. I'd rather just type it into the calculator, let the calculator do that part for me. Again, what did I do? I typed in all of my numbers without pi, and then I placed pi at the end of my answer for an exact form. Moving on. If the dimensions are cut in half, will the new surface area be half of the original surface area? Show work in terms of pi. So this is talking about scale factor. So there's kind of like a question within a question. We are talking about question number 2B. So we are talking about these originals. we want to talk about our surface area of the original times our scale factor, and because we are talking about, let me go ahead and rewrite this in pen so you guys can see it better. And since we are talking about area, the way scale factor works is because area is always squared, the scale factor for area is also going to be squared. And when we do that, it's going to equal our new surface area. So our original surface area was 2080 pi. The scale factor we want is we want to cut in half. When we cut something in half, it gets smaller, and it is the same thing as saying multiplying by a half. Now we take that scale factor and we are going to square it. So I'm going to take this 2, and I'm going to square my scale factor. And how do we do this when they want it in terms of pi? Again, we're going to deal with the numbers just like we typically do on calculators, but I'm going to ignore my pi. Be careful here, you want to put the squared on the outside of the parentheses, not on the inside. That does matter. And we get 520. Now, because we did not include pi, when we write our answer at 520, pi needs to be there. Units as well. What are our units? Centimeters squared. If you do not place your units at the end of your answers, they will be marked as incomplete. This is our work. So the question is asking, will the new surface area be half of the original? So the answer is no. Surface area is not half the original. Okay, 2C. If the cylinder is filled with Jell-O, the density of the cylinder is 23 grams per centimeter cubed. What is the mass of the cylinder? Now this one here is having you do a formula that we did in class. Density is equal to the mass over the volume. This is a formula you need to have memorized. So this formula was not provided to you on our formula sheet. The only things provided to you are volume, lateral area, and surface area, plus the Pythagorean theorem. This is something you need to have memorized. All right, the density is provided to you. We have density of 23 grams per centimeters cubed. We want to find the mass of the cylinder, and we know kind of what the volume is. They are not giving you the volume, but we need to calculate the volume on our own. So to calculate volume, we're going to go back into our formula sheet. Volume of a cylinder is pi times r squared times the height of the cylinder. So we have, trying to find my pen, oh there it is. Pi, radius was 20, height was 32. Now this one is asking you to round, so I can type in the pi into the calculator. So 20 squared times pi times 32, and I get the I get the volume at 40212.3, rounding to the nearest tenth means I'm going to go and make this into a 4. If you keep this in terms of pi, your answer will be more exact, and then you can round at the end. Okay, Now what do? We're going to take our denominator, whatever the denominator is, all of this, and you're going to multiply both sides by the denominator. So this is in my brain thinking bubble. So I'm going to multiply 40212.4 here and here, 40212.4. Now, the units are centimeters cubed, and I'm writing in the units as well because they will undo each other when you divide here and when you divide here. Let's go ahead and multiply things out. These two go away, and you're left with 40212.4 times 23, and we have 924,885.2 grams. Again, if you end up using pi, your answer is going to be more accurate here, right? And your answer might be a little bit off, but because they're saying round to the nearest tenth, it is okay to round to the nearest tenth. Question number 3 is completely different than the A, B, and C we did on 2. So question number 3 is going to be a new figure. What is the volume of a sphere with a radius of 9? Leave your answer in terms of pi. So once again, we want pi. So once again, I'm picking up my formula sheet. I'm looking for the volume of a sphere. Volume of a sphere is 4/3 times pi times r cubed. And I'm going to draw this out. A sphere, think of a baseball, basketball, looks something like this. Radius is given to you at 9 centimeters. Let me shift my papers up a little bit. So we have 4/3 times pi times radius cubed. You absolutely do not need to draw the picture. I just drew the picture to show you what a sphere is. You can just look at the formula sheet and immediately start solving for your answer. Okay, pick up your calculator. Again, parentheses are important. 4/3 times pi times 9 cubed. So to type in 9 cubed, you're going to say 9. You're going to have this, what's called a caret, this button right here. Let me shift it up. This button right here. And then you're going to type in 3. So what you should see is 9 caret 3 for 9 cubed. And we have, oh, did you guys see how I messed up? I messed up. Let's go ahead and take a step back. I even highlighted it, and it slipped my mind. Leave your answer in terms of pi. That means pi does not get into your calculator. So let's try this again. 4/3 times 9 caret 3. We get 972. Bring the pi. It's in your answer. What are our units? Centimeters. What are we trying to solve for? Volume. Volume is cubed. So be careful with the rounding and the not rounding. Pi stays. Okay. Moving on to 3b. So 3b is still talking about that sphere, still part of the same figure. So again, I'm going to draw this one out just so I have it. You absolutely don't need to draw it out. We had a radius of, what was our radius? 9 centimeters. Now we want our surface area. I'm not asking you for lateral area because lateral area does not exist on a sphere. We got 4 times pi times r squared. And again, it is asking us to leave our answer in terms of pi. So pi stays. So we got 9 squared times 4 9 squared times 4. So we have 324. Pi is in our answer. Centimeters, what did we solve for area? Area is squared. Okay. If the area was tripled, what would be the new volume and surface area? And I'm hesitating here because I'm asking, why did they want? I think what they're asking is for if the area and the volume was tripled. So they want new volume and new surface area, even though they're saying it's just the area that was tripled. That's why I hesitated for a little bit. If the area and volume, we're talking about both. So if we are talking about things that are doubled, tripled, halved, quartered, we're talking about scale factor. And so we have our little setup for scale factors. Let's start with surface area. So we have our original times our scale factor. And remember, scale factor for area is always squared. And that's going to equal our new surface area. I'm going to leave some space. It's going to work the same way for volume, except volume is always cubed. So the exponent is going to be a 3 for volume and a 2 for surface area. Now when you are tripling something, you are enlarging that value. So it's not going to be a 1/3 because that would make things smaller. We are going to have a 3/1 as our scale factor. So let's do with surface area because it's right here. Original surface area is 324 pi, and they do want things left in terms of pi. So pi is going to stay. Scale factor is going to be, like I said, that 3/1 squared. So how do I type this in? Everything except pi goes into the calculator, and then we're going to write in pi as part of our answer. So 324 times, you can just do 3 instead of 3/1, but you do, oops, that's wrong. Let's 324 times 3/1. You can just do 3 squared, or you can do 3/1 squared, but that parentheses needs to go on the outside. Sorry, that squared needs to go on the outside of the parentheses. So parentheses, then your squared. We get 2,916. And again, we need pi in our answer because we need answers in terms of pi. We did not type it in. Units, centimeters, area, squared. Volume, let me go back and see what we had for volume. Volume was 972 pi. Scale factor again is 3/1, or just 3 cubed. And again, reminder, when you're typing this into the calculator, you have to put the 3, the cubed, on the outside of the parentheses. So 972, leave off pi, 3/1, caret 3 equals, and here's our number. So we have 26,244 units, centimeters. What are we solving for? Volume. Volume is cubed. Moving on, question number 4, new figure. The state of Colorado has a population of 5 million people. Find the population density. So that's our key word here, is the population density in people per square mile. That's our key word. Hint, approximate the shape of Colorado. So it's not exact, but we're going to pretend that it is a rectangle. Population density is one of the formulas that you need to have memorized. It is not one of the formulas that are going to be provided to you. Population density is equal to the number of people or beings over the area. Okay, this formula is not going to be provided to you. So Colorado has a population of 5 million people. They are not telling you the area, but area you can just find out. This is a rectangle. So area is going to be 370 times 280. We're going to approximate that, and that's okay. So we got 370 times 280. Area for us, let me shift this up, is 103,600 population density. And so what we're going to do is we're just going to divide those 5,000, 000. Careful about your zeros and the quantity of them. So we have a population density of 482,625. Now I want to stress the rounding of this. This is incorrect. For people and beings, we want to round to the nearest whole number. So you're going to take a look at this 2. Only look at the number behind the decimal. Do not look at the numbers behind the decimal. We don't care about things that are 2, 3, 4, 5 numbers behind the decimal. So this 625, we don't look. The only one you're going to look at is that 2. And since it's less than 5, we're going to round down and keep it at 48. Now what are we trying to solve for? We're trying to solve for the population density of people, PPL, per / squared mile or mile squared. Okay, almost done. Let's go ahead and got 3 more. Okay, a circular region. So let's draw that out. A circular region with a 4-mile radius has a population density, here's our keyword again, of 6,366 people per square mile. Find the number of people who live in that region. So again, we have a formula that we need to have memorized. Population density is equal to the number of people over the area. Now they do provide the population density, which was 6,366 people per square mile. We don't know how many people live in the region, and they didn't give us area. But they did tell us what the region is. The region is a circle. So we can find the area of our own, and the circle area is pi times r squared. So we have pi times 4 squared. So our area is 16 pi. You can round, but if you do, it's going to give you a wrong-ish answer. So for these, keep your answers in exact form, because at the end we want to find the appropriate number of people. If you round early here, then it will give you something that is slightly off. Same thing we did with the original question of density, mass, and volume. We are going to multiply both sides by the denominator, which includes that pi. Okay, so we're going to take that 16 pi and multiply top and bottom by it. 16 pi, that goes away. And we have on the other side left with, again, I'm going to keep pi for right now. Well, actually, we're at the end. So 16 times pi times 6,366. This is what I have on my calculator. Here you go. And I have 31990.0613. And again, I'm giving you extra numbers on purpose. You are wanting to round to the nearest whole number. I'm taking a look at the number behind it. So this is what number I'm looking at. The other numbers, the 613, we are not looking at these numbers. This is only for population density. Be careful about rounding to the tenths or the hundredths place. You're going to have to look at a different spot when you're rounding to different things, different places. So since it's a 0319990, and we're solving for people. So 319,990 people in our circular region. If the volume of a sphere is 268 pi, what is the radius? Okay, so they are giving us the volume. So I'm going to take a look at my formula sheet for the volume of a sphere. Volume of a sphere is 4/3 times pi times r cubed. And they are telling us that the volume is this value. So I'm going to put in 268 pi as my volume. Now 4/3 stays, pi stays, and we are trying to solve for radius. First step I'm going to do is I'm going to divide both sides by pi. Do a little dotted line to separate my two sides. When I divide both sides by pi, my pi goes away. So that divides out. And this is like back in Integrated Math 1, where you're just solving an equation. I did remove parentheses around 4/3 just to show you that our next step is to multiply by the reciprocal. So let's actually put those back, and I'm going to multiply both sides by 3/4. Now when you do this, be careful. 3 is on top, 4 is like a denominator, which then allows us to remove our 3's and remove our 4's in our 4/3. Now when you type this into the calculator, again, parentheses are important. So I have 3/4 now times 268, which gives me 201, which is a pretty number. And it is asking us to round to the nearest whole number, but we're not done yet. We do need to take a cube root. So this is where I'm going to allow you to use a calculator on this. This is not a pretty number. That's okay. So watch what I do on the screen, please. You're going to type in the number 3. You're going to go to the second, and you're going to go down here where you have a caret. This will give you 3, an index, this is called an index, and then a root. So it's telling us that we have the index, this 3, inside of your radicals. So it looks something like this on paper, taking the cube root, but on your calculator it's going to look like that. So let's do it again. We're going to go 3, second, caret, type in 201, and that means you have taken the cube root, and we have 5.85. Now it is asking you to round to the nearest whole number, so that means we are rounding to 6. Now what are we trying to solve for? Radius. Radius is a singular, so that means our units are just centimeters. All right, ladies and gentlemen, we made it to the end. One last question. Given a surface area of a cone, so let's go ahead and write in our formula right away. Surface area cone, so that means lateral area plus pi r squared. And I'm going to write in my lateral area formula because Otherwise, I won't know what lateral area is. Pi r times slant height. I'm going to combine these just to show you that surface area is your lateral area of pi times r times your slant height plus pi r squared. I'm going to highlight that for you so you can see what I'm talking about. This lateral area is this lateral area here. Okay, let's keep reading. And its radius is 3 meters. So we know that its radius is 3. And we know that the surface area is 50. So let's plug in some values. We have 50. Oh, and look, I have another radius here. We don't know the slant height. Approximate its slant height to 3 decimal places. So we are rounding on this one. So the first thing we need to do is we're going to go ahead and evaluate any numbers that we have, and then we're going to start to get rid of things. So I still have 50 here. I'm going to rearrange this and say we got 3 times pi times our slant height plus we got 9 pi. Now it is your choice because they are allowing you to round. If you start typing this into the calculator, you are going to be rounding early, so your answers are going to be slightly off. So keep it. You have to do this question in particular steps. If you start to combine things, it's going to go really wrong. So the first thing you're going to do is you're going to see this adding a 9 pi. You're going to go back and revisit the world of IM1, and you're going to subtract 9 pi both sides. That eliminates the 9 and the pi, and we're left with 50 minus 9 pi. If you wish to start typing this into the calculator, go ahead. However, your numbers will end up being off, and if you round too early, your answer is going to be wrong. So be careful here. Bring down your 3 pi times the slant height. And since we are trying to solve for the slant height, we're going to keep the slant height, and instead we're going to divide by that 3 pi. Threes go away, pi's go away, and you are left over with your slant height. And now we can type this into the calculator. When you type this into the calculator, you must place parentheses around your numerator. Otherwise, your calculator will do things that are wrong. So how to type this in? 50 minus 9 pi. Ooh, parentheses. I forgot parentheses. Let's try this again. Open parentheses, 50 minus 9 pi, close it, divided by, open 3 pi, close it. So like I said, parentheses are going to be really important. If you don't place parentheses, it will give you a wrong answer. Enter. Now this one is asking you to round to 3 decimal places, so I'm going to take my answer. I'm going to count to 3 decimal places. 1, 2, 3. That means I am looking at the next one. I am not looking at the 6 and the 4. I am only looking at that 1, the number 1. Since it is 1, it is less than 5, we are going to round accordingly. So we have a slant height of 2.305 units. Slant height is singular. Our units are meters. Again, you don't put your units, it will be marked as an incomplete answer and points will be removed. Alright, beautiful people, thank you so much for watching this video, and I will see you in the next one. Bye!